All right, so we are going to be looking at domain and range. Domain is your input values, they're your x values, they're your independent variable. It's what you're substituting into your function. So basically, too, if you kind of look on your graph there, if you're looking at a graph of a function to figure out domain and range here, domain, you want to look the leftmost x value, whoops, and then the rightmost x value. And then to figure out the range, you want to look at your bottom y value and you want to look at your top y value. And so a range there is your output values, your y values, your dependent variable. So it says determine whether the curve is a graph of a function. If it is, state the domain and range. So remember, to be a function there, it has to pass the vertical line test. So basically a vertical line test here. So to pass the vertical line test, you take a take your pen or your pencil and just go ahead and as you go across the graphs, I'll just draw them on here so you can see what I'm doing. I'll just take my pen and go across there. If it only cross a graph in one and only point there, as you take a vertical line, you go across your graph there, then it's considered a function. So this one here in part A there, yes, it's a function there because a vertical line will only cross through one and only one point at any time when I go through the graph. So yes, it's a function. And because it's a function, I'm supposed to go ahead and state the domain and range. So the domain here, I'm going to look at the leftmost x value. So if I look to the left of my graph, the left of my graph is right here. And my right of my most graph over here is over here. And so what's my left of x value? That's a -1, -2, -3. So it looks like -3. And then over here, 1, 2, 3. So it looks like it's up there at 3. So if you want to write it like this, x is greater than or equal to -3 and less than or equal to 3. So that means it's between -3 and 3. Another way you can write that is you could use brackets. If it includes -3, like there's closed dots on there, and there is, I can do -3, 3 bracket. So it means it's between those two values. So then the range has to do with bottom to top. So I'm going to do range here in red. So my bottommost y value is down here. My top one is either the left one or the right one. I'll just pick the right one here. So bottommost y value, the y value down here at the bottom down here is 0. So I can write this 0 less than or equal to y, less than or equal to whatever the value up there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, or I can put brackets around it since they're closed dots. It goes from 0 to 9. In other words, it includes that point. There's not open dots there. If it was open dots, you'd put parentheses around them, but in this case, they're closed dots. And then part B, is that a function? Well, use the vertical line test. I'm using the vertical line. It's only going through one point at any given time. And so, yes, this is a function. Because it's a function, I have to state the domain and range. So domain, range. Domain, I'm looking for the leftmost x values. So my left is here, my right is here. What's my x value there? -1, -2. What's my x value here? 1, 2. So x is in between -2 and 2. So if you want to do the brackets, it'd be bracket -2, 2. You have to use brackets. Do not use parentheses because it includes those 2 points at the ends. And then range here, that's bottom to top. Well, the left and right and the bottom to top here end up being exactly the same, but I'll do it in green. So my bottom y value here is -1, -2, -3, -4, -5, -6, -7, -8. So bottom y value is -8. Top y value, 1, 2, 3, 4, 5, 6, 7, 8. So it goes from -8 to 8. So how do I write that? -8 to 8. So either way you can write it, whichever one's easier for you to do. Part C, Again, does it pass the vertical line test? Well, if I draw a line, let's say I draw one right there, oops, it goes there in 2 spots. It hits the graph, so no, that is not a function, so don't have to do anything else. Let's go to the next one, letter D over here. Does that pass the vertical line test? Yeah, as I take a line and go through the graph, it only passes through at one and only one point. Therefore, it's a function. Therefore, I have to state the domain and range. So it looks like on these ends here, it looks like these keep going. They don't stop. So if they keep going there on the ends there, then we gotta go ahead and figure out what those values are. So this one here, leftmost x value, left, it's going to keep going down, and as it goes down, it's also going to keep going over to the left here. So if I kept drawing it out, x value is going to keep getting bigger and bigger, or smaller and smaller in this case, because it's going to get bigger negatives. So, and then over on this end here, as this goes up, it's also going to go to the right. So it's all real numbers for your domain. For your range, it's just going to keep going down, 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 down. This is just going to keep going up, 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 up. So this is all real numbers as well. There's nothing, like it's not like all it does is both the ends both go up. If both the ends went up, then it'd be a little different scenario. So, and then let's look at letter E over here. Again, does it pass the vertical line test? Yes, it's only going through one point at any given time. And look here, here's the kind of the tricky spot. Let me show you the little tricky spot after I erase these. The little tricky spot is right here. So it goes through both this closed dot and this open dot here at the same time, but this is an open dot, so it means it doesn't exist there. And this is a closed dot, it means it exists there. So it's not like that makes the vertical line because this is an open dot there. So we're okay with that. That there is, yes, it's a function. If they were both closed dots at where I drew that vertical line, then we'd have a problem. It would be a function. Okay, so then the domain here, look to the left. What's the leftmost x value? And leftmost x value there looks like it's a -6. What's the rightmost x value? Um, you know what? Maybe these keep going. We can make them keep going. How's that? We'll put arrows on the ends. That's not very clear, but let's go ahead and let's put arrows here at the ends of those graphs. If there's arrows there at the end, that means it keeps going left forever and ever and ever and ever. And this one up here is going to go to the right forever and ever and ever. So because that's true there, you're going to keep getting more and more negatives to the left here. And then over up here at top one here, the top graph up here, you're going to keep getting bigger and bigger x values there to the right. So your domain here is all real numbers. Now the y's, on the other hand, are a little more picky about that. Your y values here, your bottommost y value here is -1, and your topmost y value here is 2. But notice that's the only values you're going to get. You're either going to get -1 or you're going to get 2. So in here, I'm going to say y equals -1 or y equals 2. Or some people just draw a little set and say -1, 2. I usually say what it's actually equal to, y equals -1 or y equals 2. Because those are the only two values that it actually ends up equaling. It doesn't equal anything else. So there ends up being our domain and range.